Children, the last video we have learned about Arrhenius concept and Lowry-Bronsted concept. Third concept, Lewis concept. Here, a scientist in 1923, Gilbert N. Lewis, proposed a concept for acids and bases. He considered the electron pair to define acid and base. According to him, an acid is a species that accepts an electron pair. And base is a species that donates an electron pair. So that we call as Lewis acids and Lewis bases. Lewis acids means accepting electron pair. Lewis bases means donating electron pair. So a Lewis acid is a positive ion or an electron deficient molecule. Lewis base is an anion or neutral molecule with at least one lone pair of electrons. For example, reaction between BF3 and ammonia, boron trifluoride. Boron, atomic number 5, 1s2, 2s2, 2p1, 5. Ammonia, here nitrogen having atomic number 7, 1s2, 2s2, 2p3, 2p3. Now see this boron, outermost configuration 2s2, 2p1. So BF3, 2s2, 2p1, 1, 2, 3. Here there is no electron to accommodate one more bond. Here nitrogen you see atomic number 7, 1s2, 2s2, 2p3, that is 5 electrons. Ammonia, NH3, 3 electron has gone, remaining 2 electrons remain as lone pair. Now this lone pair can be donated to boron. Boron is electron deficient, N having excess electron. So these 2 electron or this electron pair can be donated to boron. So boron is an electron deficient. So it is an electron rich. So this can be donated. This accepts. So this is called Lewis acid, which accepts the proton, that is called Lewis acids, which donates the proton, that is called Lewis base. So since these pair can be donated to boron, the bond BF3, here NH3, and this bond is called coordinate covalent bond, single-headed arrow. Since here in boron the 2p orbital is vacant, to form the half-filled it needs 2 more electrons having 2p1. Already p orbital can hold 6 electrons. Now it is having only 1 electron. 2 more electrons it need to become half-filled. That 2 electrons only it got from ammonia, that is nitrogen. So nitrogen, this is ammonia, act as a Lewis base which donates proton, and this BF3 which is accepting called electron acceptors or Lewis acids. So here it formed a coordinate covalent bond, one-headed arrow. So already we have learned in coordination compounds the ligands act as Lewis base, and central metal ion accepts a pair of electron from the ligand, behaves as a Lewis acid. So generally what is meant by a Lewis acid and Lewis base? The difference it is given in a book in page number 5. Generally what will you say about Lewis acid means, number 1, Lewis acid is an electron deficient molecule. Lewis acid having vacant orbital. Best examples BF3, AlCl3, aluminum trichloride, beryllium difluoride, BeF2. Here what is Lewis base? Molecules with 1 or more lone pair of electrons. For example, ammonia, water, alcohol, ether, amine, etc. Number 2. What are Lewis acids? All the metal ions Fe3 plus, Fe2 plus, Cr2 plus, Cu2 plus, these are all Lewis acids. What are Lewis bases? F minus, Cl minus, Cn minus, SO4 2 minus, these are all anions. Next, molecules that contain a polar double bond. Polar means having charge, positive, negative, polar double bond. SO2, CO2, C double bond O, double bond O, CO2. Here, molecule that contain carbon-carbon multiple bond. That means it can have double bond or triple bond. That is called multiple bond. CH2 double bond CH2, CH triple bond CH, etc. Next, here fourth difference, molecules in which central atom can expand its octet due to the availability of empty d orbitals, because it is having vacant orbital, vacant it is filled from the ligands. Here all metal oxides, for example CaO, MgO, etc. Next, the last one, fifth one, carbonium ion. Carbonium means positive species. Here carbanion. Carbanion means having negative species. So these are the differences of Lewis acids and bases. It is clearly given in page number 5. Here at least you can learn 3 differences between the Lewis acids and Lewis bases, and the Lewis concept given in page number 4. Lewis acid is a positive ion that accepts an electron pair. Lewis base is a species that donates an electron pair. Clearly given in the book. You can go through and mark in the book.